Welcome to Thursday. Yay. Tomorrow's Friday, which is good, but we're still going to be learning today. We're still going to be learning tomorrow. And if I had time, I'd actually record my lesson for tomorrow for you guys, but I don't. So let's learn. Does it start here? Yes. Okay. So this is where we left off. We finished with this one. Just as a reminder, can someone please, welcome to Thursday. Can someone please, can you please circle one of the edges with that green? It's already activated for, or if you don't feel confident, if you don't remember from yesterday, please ask somebody else. And it's okay to be wrong here. This is not a test. You will not get a failing grade for the quarter that I turned in yesterday. Circle one of the edges, or highlight one of the edges, or something, or outline one of the edges. Okay? Thumbs up if you agree. Okay, thumbs sideways if you're like, I don't know what class this is, let alone if that's an edge. Okay? Yep. Hand it off to somebody else. Here, let's make it a highlighter. Call on somebody else, please. Can you please shade in or highlight or circle, whatever be appropriate, an edge? Sorry, we just did that. A face. Oh, that's not. Here, can you hit the color palette thing to the upper right? Let's make that bigger. Go here. There we go. Yes. Okay. Isn't it though? He's doing a really good job. All right. And then call on somebody to circle a vertice. I've had one boy and one girl, so you can choose either gender. But you will choose in 3 seconds. 2 seconds. One. All right. So go ahead and click the red pen. And go ahead and circle one of the vertices. Beautiful. Thank you, sir. All right. So if you could put in your own words, possibly from what we did yesterday, but maybe a little bit better in your own words, because that's that helps me understand that you know what it is. Can someone please describe what a face is on a 3-dimensional shape? Potter, let's try it. She wasn't here yesterday. Let's go for it. Is it like the side, or is it a side? Very good. Yes, it's one of the sides to a 3-dimensional object. Good. Yes. It's a flat surface as well. Beautiful. So we have a flat surface that's a side of a 3-dimensional shape. How about, so let's count these. So how many does this have? We have, let's do it. Let's do that group counting thing again. I loved it. Ready?
1, 2, 3, 4, 5, 6.
Let's see. There's a 6, but it's back there, so I'm going to do a 6 backwards. There. Since that's on the back side of it. Okay, 6. Beautiful. So there are 6 sides to this guy. Ew. There. And then how many edges do we have? Let's see. Count them in your head. Count them in your head, and then I'm going to call on Maddie to see if she's got it. So we've got, I'm going to actually do this so we can see. See if you agree with Maddie, because I said I'd call on her. What do you think? Got 11? How many did you get? I got 12 as well. Okay. Because if you think about it, we have 2 squares. 1, 2, 3, 4. 1, 2, 3, 4. And then there's 1, 2, 3, 4. Holding those up. 4, 4, 4, 12. You see where the 12 are now? Good. Yep. 4 times 4 times 4. Well, you're right. Yeah, that'd be 4 cubed. Okay, then we have the vertices, and the vertices are going to be where they meet, which is going to be 1, 2, 3, 4, 5, 6. So there are 8 vertices. So vertices are where edges meet. Edges are where sides meet. Sides are where between edges, right? They're all related. They're all related. Good. And this shape here, if it were unfolded, it would look like this here. Okay, remember these lighter blue ones, that's where if we were making them three-dimensional and we had the time to do that, if we had a class that was more than 52 minutes long, we would do that. I should almost have you guys do that for homework. No. Then we have a cylinder. It has 2 congruent parallel bases, but bases are circular, not a polyhedron. What's the definition of polyhedron? Did we write that yesterday? What is a polyhedron? What's a polyhedron, Brooke? 3D object with a flat surface. Now, is this a flat surface here? No, it is not a flat surface. It has 2 flat surfaces, but it's not a flat surface. It is rounded. Okay? It is rounded. So, if you had a gerbil wheel, if you had a gerbil wheel, and your gerbil was running in it, let's see here. Here's your gerbil. Yes, that's horrible. Never mind. Forget it. Forget it. Hi, sir. Thank you. Okay. So a cylinder has 2 congruent parallel bases, but the bases are circular, not a polyhedron. How many faces do we have? Now, does a face have to be flat? Does it have to be flat? What is it? What is the definition that we found for flat surfaces? So we have, as far as a cylinder goes, there's only 2 faces. However, when you lay it out, how many faces are there? So the net has 3, but the cylinder itself has 2. So cylinder, since we're talking about a cylinder, there's only going to be 2 because it has to be flat. Then the bases, there's going to be 1 base, 2 edges, and 0 vertices. There's no point where edges meet. You can look over at Brooks to see what we had for the one before that. Okay, moving right along. Pyramids has 1 polygon-shaped base and 3 or more triangular faces to share a vertex. So, if we had this shape here, which is a hexagonal. I don't know which emphasis to put on the wrong syllable. If we were to untie this guy, if we were to open it up from right here, if we were to go open this spot and it would just open up, each side would be opening up like a little flower. There's like all the leaves and stuff like that. The flowers in my backyard, my bush in my backyard had no little buds, and then all of a sudden it's like starting to pop out. So that's kind of what it's like. So here's we got a little flower right there, and that's before this early spring, and this is what's happening now. Okay? So it is 3 or more triangular faces that share a vertex. Okay, it's triangular faces that share a vertex, the 1 vertex on the top. So for example, we have a rectangular pyramid is going to have 1, 2, 3, 4, 5 faces. Ew. We are going to have 1 base. Ew. Who doesn't have base? Oh, cool. Well, the thing is, I do want you to write that in there because can someone remind me, without looking back earlier in their notes, how are prisms and pyramids identified? Yeah. Yeah, it's all about the base. Okay? Not sides. No. No. Edges. Okay, edges we have, let's count them out. We have
1, 2, 3, 4, 5, 6, 7, 8.
8. Okay. So we have 8 there. So we have 8 edges. 8. There were 8. And the way that we could do that is, you know that there's a rectangular base, and there's 4 of those, and all 4 of those bases have to meet up at the top. So that would be like 4 times 2. Vertices. Yes. Because I wanted to do some think, pair, share today. So then we have vertices, which are going to be where these guys meet. 1, 2, 3, 4, 5. There's going to be 5 of them. 5 vertices. That's where edges meet. One of these vertices is pretty cool because it has every single of its sides meeting up with it that isn't a base. They're for 7th graders. So in 1 year from now, you get to do that gummy bear thing. Then we have a triangular pyramid. Okay? Yes, it is. Huh? Nice. So, no. Triangular pyramid, we have faces. I'll just count them out. We have 1, 2, 3, 4. There's going to be 4 of them. Okay, there's going to be 1 base, and it's going to be whatever one of those. This shape here is what I have made for my 7th graders. Yep, that's this guy. Here it is IRL. The base is clear. Okay. Then it'll be a rectangular prism, a square prism. Then we have bases. There's only 1 base, quiet. There's only 1 base, and what is the shape of that base? Yeah, it's a triangle. Because it's a triangular prism, so that's going to be the base of it. Yeah, or pyramid, pyramid. Then we have some edges. Now, when we're doing edges, to be clear, make sure you're thinking of it as a 3D object whenever you're looking at the edges, because there's a couple edges here that are going to be sharing the same edge. Like these guys here, if they were spread apart, it could be this guy and this guy. Okay? That would be the same edge. So we have 1, 2, 3, 6. And this is how it would look to outline what we just did there. We would have the one that I did, 2, 3, 4, 5, 6. Those would be the edges on that guy. Okay? So we have 6 edges. And then with the vertices, we have 1, 2, 3, 4. Ooh. Senorita Beavis and Senorita Steening would be very happy to hear that. Okay. So that's the size of the triangular pyramid. That's not the button I meant to push. There we go. A cone. Ooh. A cone. Quiet, please. A cone is a circular base and a curved surface that comes to a point. Shush. You guys aren't even talking to anyone. You're just talking. Stop. It's making noise. Every time I turn around, I still hear the voices, but nobody's like this. It's just looking at me. So if you're talking to me, I can't hear you. Not a polyhedron. Not a polyhedron, okay? Because of the curved surface. So we have 2 faces in the net. So that, oops. We have two faces in the net because those are flattened out. Then with the edges, there's only 1. Because the edge is going to be circular. Okay? We only have 1 base because it is a circular base, as it says right here. Then we have vertices. There's only going to be 1 technically because that's where the cone comes together. Yes.
So, would you do the bases like for in the net, or would you do it in the
If it were actually in a 3D, because when we're finding the area of this, when we're finding the area of that, it's going to be, we're going to lay it out like that so we'd appear to have a face. But the vertices, that's where the edges meet. Would this really be an edge necessarily? No, not really. So does it have any vertices? Are there any edges that meet? Can one edge, if you have a basket full of one edge, can that one edge meet another edge in that basket? No. No. That's why when you have only one more something of an animal, that's the last one, guys, right? So there's actually going to be 0 vertices. Okay, quiet. Yes, Taylor.
so what? How many bases would it be if you're not like
There would be just one, which is the base. Yeah, if we were not looking at the net, because this curved surface here, that's not a cone with arms. Yeah, that curved surface there says that it can't be a base. Papa? Wait a minute before we get done with this. Yeah. Nope, not right now. So name these 3D figures. This is what we're going to be doing. This is what we're going to be doing for practice for the next 15 minutes or so. Not these ones here, but stop talking. It does not require you to speak or make noise. The only noise I should have heard was just turning the page, and that's it. Okay? So what type of shape is this, and how do we know? Somebody raise your hand. Give me one thing about it. Yeah. This shape right here, yeah. It's a prism, okay? No, I disagree. Okay, I'm going to say hexagonal. Hexagonal. Because it's a hexagon in the base. Okay, something else. DJ? Prism? Nope, that's what somebody else said a minute ago, and I said incorrect. Avery? Nope, not a prism. Miguel? What? There are some triangles on here. There are triangles on here. What kind of prism has triangular sides? Quinn? Yes. It's a pyramid, guys. Do you guys still do the Egypt in 6th grade? Okay, then what? Come on. I believe in you. Taylor? Pentagon, yeah, because pentagon is 5 sides. There's only 5 there. Wow. Well, it's a good thing you're using. It's a good thing you're using pencil in math, then, like you always should, except for when you're checking your work, right? Are you expected to have a pencil in class every day, sir? Yeah. Did you not know that before today, sir? Okay, good. So make sure you bring a pencil. So it's a pentagonal pyramid. Here's the way that you would know that. There are triangular sides. There is a vertex at the top where all the sides are shared at the same spot. Okay? It almost looks like a Nintendo version of a cone. Okay? Yeah, it looks like a version, yes. Okay, Nintendo version of a cone, but it's pixelated, so it's got sides. Okay? Few hexagons. Or it's few, yeah. Is that how they? Yeah. Now, how about this one? What's this shape here?
Cylinder.
Okay, it is a cylinder. Simple as that.
Cylinder.
Cylinder. It is. Shh. Stop. It is a cylinder, and you know this because it has a circular base. Okay. It has it has 2 flat surfaces and no vertexes. Then we have this guy here. We have that shape as a base. Avery? Triangular prism. Ooh. Here, I can start to write bigger. A triangular prism. So what is it? What is that, guys? Someone raise your hand. Yes. Shh. No, I said raise your hand. It's a cone. It's a cone. That also looks like a face. A cone. And how do you know? How do you know that it's a cone? Stop whispering. I'm never putting you guys in seats next to each other again. In general. How do you know? Keep going.
It has one base or a circle.
Yes. One circular base. Beautiful. One circular face in the 3 dimension. Yeah. And no vertices, exactly. It has a point, but that's not a vertice because that's where edges meet. Okay? Then we have Avery, what's this one on the top left? Rectangular. Now, can someone tell me what's up with these? What is that? Okay, those are folds. Good. Don't think that that's a side. That's just what you would see if we were cutting them out. Good. So you said a rectangular, a squared pyramid. Yes, it is a squared pyramid. And if I were to do it 3-dimensionally, it would look like this. That's what it looked like put back together. Okay, so it is a squared pyramid. Pyramid. Let's go down. Down. What is that net? These are nets. Can you guys write nets if you don't have it? These are nets. Okay, Nick? It is a triangular prism. You are correct, sir. How do you know that? Beautiful. Yep. It has 5 faces, and 2 of those faces are triangle, and this one could be the base. All right. And if I were to put it 3-dimensionally, it'd be like this. Like that. We'll do this one too. Good. Then we have this one over to the right. There. Audrey, you raised your hand earlier. I've been calling you. What do you think this guy is? Do you want to see the 3-dimensional version of it? Okay. Do you want it standing up or laying down? All right, let's stand it up then. Looks like that when it's all put together. Looks like a cube. What if I did this? There. What is the shape of the smallest guy here? It's a square. And what shape is this guy when you don't think of a square? Yep, so that means that it's going to be a square. It's either going to be a prism or a pyramid. Which one is that? Does this come together on the top, or is it the same as 2 bases? Yep, it has 2 bases, which means that it's going to be a square prism. Square prism. Square prism. Then we have like a throwing star. What do you think this one is, Abby? You have triangular, correct? Triangular pyramid. Triangular pyramid. Triangular pyramid. And put that one together, it would look like this. And that would be looking at it from the bottom. Good. So as far as comparing and contrasting prisms and pyramids, let's create a Venn diagram. Is there one on here?
Yeah.
Well, on here, that is, on the PowerPoint. No. So let's create a Venn diagram. So which is on the left, which is on the right? Let's go. Yeah. All right. So do you want something? You had something out there? Okay. If you got something else to add, raise your hand, and we're going to pass this off. We're going to spend 4 minutes. 4 minutes doing this, and we're just going to be handing the stylus off to each other. If I could reset my watch. We're going to spend 4 minutes of writing down any ideas you have. You can put things that they have in common, things that they have that the other one doesn't, that sort of thing. Just to remind you, hope that you've seen lots of Venn diagrams. But things that prisms only have is going to go on the left. Things that only triangles have is on the right. So you can just, yep. Okay. Circle based on prism. Are there any Okay. Is a cone more a pyramid or a prism? Pyramid. But can a prism have a circle base? So where should it go? Yep, in the middle. In the middle. You can do the big open circle, not the X, but the big open circle right here, and just just go over that circle base. So we're still working. You guys can. I want you guys writing down ideas as this is happening, please, because anything that you can add, you can go. You can do more than the people up there are writing. Oh, go to the color wheel thing. Then go to, hit the brush type, which is a marker. Yep. Now you got it. I am handing out what you're going to be working on before you get the homework, but I do not want you to start this yet. No, that's going to be the classwork. That's what you guys are collaborating on, because then you're going to do homework by yourself. Do you not know where to turn this in? I know. I said write absent on it, then you turn it into the turn-in bin for 6th grade. You know where that is? It's below the 7th period bin. All have bases, circle bases, vertices. Okay, good. They all have vertices. If that's too thick, we can go thinner. So go ahead and erase that with a small eraser. Yep. And you don't need the word both there because that inside that Venn diagram. So go ahead and click these and the marker. Good. Okay. Hit this one. Depends on the shape of the base. Good. Okay, we got time for one more, and then we'll do some others. Meet at the top. And by meeting at the top, what does the person who wrote that meant for the pyramid? What do they mean by that? Meet at the top. Yeah.
All the bases, like, they come from the base and then they, like, go up and then...
What is that called where they meet? Nope, I'm asking Skylar.
What is that called?
Nick, what is it?
A tip.
No. It's a vertex. A vertex. Yep, remember? Yep. Yeah. Nice. Have two bases at top and bottom. Good. That's fine. Top and bottom. Here you go. So they both have a base at top and bottom, same shape. Right? That is the same shape. There's a pyramid. Meet at the top. At a vertex. That's better. At a vertex. Good. How about triangular sides? Triangular sides. Not cone. Then this one has rectangular sides. Rectangular sides. Even if it's a cube, squares are rectangles. Because rectangles are parallelograms with 4 90-degree angles. Yes. What do you have? Last one.
The pyramid has one base.
Meet at the. Oh yeah, one base. Cool. So that'll be that. I'm going to stop the video now, and we are going to work with your partner to do the assignment that I just passed out. Since you won't hear my voice anymore, lucky you. Have a great spring break.